So solve this one. That's how we're going to start. So I'm hoping you have pondered and thought, well, if you can factor it, you should. Would you agree that that's a huge rule? It's come up many times. Yeah, it has. If you are willing to admit it, it has. And it's going to come up in this problem. And you might be like, that doesn't factor. Not yet. Okay. So then what's the next rule? Well, one of many rules I've given you over time is clear the fractions. Do you agree this has fractions? Yes. Therefore, you should clear them. So what clears them? Multiplying by the denominator. But could you multiply by 8 and 16? Yeah, but there'd be a slightly smarter way. Yes?
Multiply them all at once?
So multiply by 16?
No, multiply by every denominator at the same time and then cancel the ones that can.
I do agree with you, but why is multiplying by 8 just as good as multiplying by 8 and multiplying by 2? Do you get how this will cancel and this will reduce? And you can reduce away a fraction? So by multiplying by 8 first, all of a sudden I have 4x equals 8 over x plus 2x. Now, could I have multiplied it all by 2? And yeah, but it didn't really need to. Because multiplying by 8 knocked out both things. It took out both denominators at once. But a lot of kids will stare at this for a long time because they're like, I don't even know what to do. I don't know how to put them together. Do I need a common denominator? No, you don't need a common denominator. You just need to clear the fractions. So, Miss Pat, what do you multiply by next?
I'd say x.
I agree. Everybody multiply by x. And now I have 4x squared. I'm going to write it up here so I have more room. 4x squared is equal to 8 plus 2x squared. Are you aware that that's a quadratic and therefore you have to now start looking about trying to, if you can factor it, you should, but not yet. Don't factor it yet, because why? Yes, we're going to get it all onto one side and make it equal to 0. So clean it up so it's all equal to 0. Now, if you subtracted 4x squared from both sides right now, it wouldn't be wrong, but it would be way hard to factor because the lead term would be negative. If the lead term is negative, you'd have to, listen, you're going to need this later. If the lead term was negative, you'd have to factor out a negative. But we can avoid that right now by just moving these two things to the other side. And that's gone, and it equals 0. And I have 4x squared minus 8x minus 2x squared. Oh, wait, the 4x squared and the minus 2x squared, that makes 2x squared. Something went wrong.
I don't think it's 8x, I think it's just 8.
Oh, it's just 8, thank you. That's not an x, that's just an 8. Okay. And now, would you agree with me that if you can factor it, you should? Can this factor? You might think it can't, but it can. 2 comes out. What you got? If you can factor it, you should. It factored again. Liam?
X plus 2 and x minus 2.
Yup. I got 2 answers. X equals negative 2. X equals 2. Now that involved so many things. That's why it's a real typical problem on the ACT.
When is the ACT?
You can take it anytime you want to, but the high school pretty much strongly encourages you to take it middle of junior year. But I recommend that taking a practice one, I would aim for summer after sophomore year is a great time to practice because it's not your junior year yet. You still have time to like prepare so that when junior year hits, you would do well on it. So I think summer after sophomore year, even during sophomore year isn't dumb, but summer after sophomore year, most of you guys don't have hardcore jobs yet. You have some time. That's a great time to take it. Yes.
For this equation, since it's so simple, couldn't we have just subtracted 2x from both sides and then solved like normally?
So what would the answers have been?
The exact same.
Exactly. So you're looking back in time and saying, geez, I could have just bought Bitcoin back in 2009. That would have been smart. So yes, that would have been smart. Both. So could you do it another way? Sure. There's more than one way to solve a quadratic. And you could have even used the quadratic formula if you wanted to. Guess what the answers would have been? 2 and negative 2. So either way, there's my answers. I'm done. So what's today about? Solving these? No, you're supposed to already know how to solve that. This was from the top 20. Except there wasn't an x in the denominator, but it's still the concept multiplied by the denominator. Okay, so this is not supposed to be new. All right, you're going to find that that's the way today is. A lot of putting together a whole bunch of little pieces, like it all comes together into one question. Clearing fractions turns into solving a quadratic, which turns into, if you can factor it, you should, which turns into the answers, finally. All right, but one thing I want to warn you about. In this case, both answers worked, but a lot of times these problems often have ones that don't work. It'd be like if you worked at a supermarket late at night in a sketchy neighborhood, they might want to warn you, like, this could be a dangerous job when you're working it alone in the middle of the night in a neighborhood that's a high crime neighborhood. They might want to warn you that ahead of time. Like, that's something you'd want to know, okay? Well, these, a lot of times, and on your upcoming test, a lot of times, one of the answers doesn't work. Like, just randomly. Like, you solved it right, you did everything right, but yet one of these two numbers just doesn't work. Sometimes it's because of the domain, meaning like, do you get if these were times? You can't have negative time, and the negative 2 would go away. What if they were the lengths of the sides we should cut out of the corner of the box? Do you get, we got a negative side length? That's not real. You can't have a negative side length that you're going to cut out of the box. So that one gets thrown out. So sometimes they get thrown out because of that. Other times, you just actually put the number in and it doesn't work. I'd like you to check if 2 actually works. Some people don't know how to do this. I'm just making them realize. How do you check if 2 actually works? Yeah, you put it in here. And is 1 equal to 1/2 plus 1/2?
Yes.
It worked. Okay, my point, though, is that sometimes they won't. You check one of your answers and it just won't work. Sometimes it's because of the real world problem concept, but sometimes it's just the math just won't work, even in a normal equation. All right. On this one, how would you start? Yes? Factor it. The faster you get used to that, the better. So often, it's factoring. This one, I think everybody would have known you had to factor it. Eventually, you would have figured it out. But then once we got it factored, a ton of things become clear. I'd like you to see how many of these you'd be able to answer. Except we're not going to graph it. It takes too long. But you should know how to start graphing it, at least. Noah, can you factor this one? Bottom or top?
It would be, top would be x plus 5, x minus 5, x plus 3.
Nice. I'll pick on somebody else for the bottom. Can you factor the bottom?
Yes, it would be x plus 3 x minus 3.
Nice. Did you notice that something would cancel, Miss Pep?
Yeah, the plus 3 and the on both x plus 3 are both going to cancel.
I agree. I'm just going to actually creatively change this to the +3 over here, and this to the -3, so that I can cancel these a little cleaner. Yay, there's my simplified function. Is it exactly the same as the original? No. The original had a weakness for both 3 and -3. This one doesn't. So you got to be careful. They're not the same. The original one and this new simplified one are not the same. One of them has a weakness for -3s. The other one doesn't have that weakness. Okay, so use that to tell me the domain. Hint, I just put it on a number line and say what it can't equal. And put empty circles where it can't equal that. And then fill in everything else. That's as fast as you can get. You want to use interval, go ahead, but it's not as fast as this. And then solve for the X-intercepts. Ooh, I told you earlier in the hour where you could find X-intercepts. If nothing else, the X-intercepts are where Y equals 0. Good. So you could stick that in for f of x, and then you could go, oh, I guess I need the top to be 0. Because the X-intercepts aren't what make the bottom 0. What makes the bottom 0 is the vertical asymptotes. So that's where you're going to find your X-ints on the top. On the bottom, that's where you're going to find your VAs. What do you think that stands for? Vertical asymptotes. All right. Go ahead and try to finish this. I will pause for a moment while you do. Go fast, though. Act like you're on the ACT and time counts. So this is all review. Okay, Zodi, tell me one thing you're confident in. X-intercepts, Y-intercepts, vertical asymptotes, holes.
One of the vertical asymptotes is at +3.
You got it. So should I say X equals 3 or Y equals 3? Hint, I said vertical and horizontal. In other words, that's a hint on whether it's X equals that or Y equals that. Okay, so give me your final answer. X equals 3 is correct. Raise your hand if you had that for the vertical asymptote. Okay, if you didn't know that, the verticals, remember, they come from the bottom like this. All right, Senna, tell me something else you know.
There'd be a hole at -3.
All right,
Or like -3 would be the X. And then
I agree. Wait. So I agree. X equals -3 is the beginning of the hole, so it's -3 comma. Now I want to know, how many of you have already figured out the Y part of the hole? Oh, that's a fair number of you. Sana, can you do it?
I said 4 things.
So how'd you do it?
I put -3 in there.
You put -3 in like here and here. That's a good way to do it. Final answer was what over what?
4 thirds.
All right, it's probably started as 8/6 and then reduced to 4/3, and you are right. Okay. Why couldn't you just put it back in the original? Because watch, when you put the -3 down here, it would just crash immediately. The function would die. All right, next up, X-intercepts. There's usually 2. I would have thought that the X-intercepts would have been X equals 5 and X equals -3. But what's the problem with that? Those are the 2 things that make the top 0.
There's a hole at -3.
At -3, it doesn't exist. You're right. So that can't be right. All right. The Y-intercept is where? What?
X equals 0.
Good. So I just go in here, and I put an X equals 0. In either equation, I'm choosing this one. X equals 0, 0, 0. All that's gone. 15/9, same as 5/3. Could you put it over here? Yeah, you get the same thing. If you'd have put it in here, 0 here and 0 here, you'd get 5/3. Either way, it's 5/3. That would be marked wrong. Why? Yeah, the Y-intercept is where X equals 0. 0 comma 5/3 would be marked right. Okay. The horizontal asymptote. Is this, I always say, ask Bob about the horizontals. Justin, is this a Bob?
No,
What is it?
it's a sum.
It's the same on both. X squared on the top, X squared on the bottom. So what's the rule for same on boths?
The ratio of the lead coefficients.
So it's y equals 1 over 1. If you didn't have that memorized, you got some work to do. There's 3 rules. Bigger on top, bottom, bigger on top, and same on both. This was the same on both, so it's y equals a ratio of the lead coefficients. In this case, 1 and 1. Y equals 1. And then if you're going to graph it, besides putting the asymptotes on there, and the whole, what's your best tip for graphing? I call it your best friend in graphing. Yes? XY chart. All these things that I keep telling you, they're huge. If you hit a graph and you don't know how to do it, it's because it's a top 20 thing that you're still not good at. Graphing from an equation is one of them. Okay, let's move on. This is horizontal asymptotes. There aren't any slant asymptotes. I'll talk to you about those in a moment. For right now, it's just bigger on bottom, bigger on top, or same on both. You have 20 seconds. You should be able to get these answers in 20 seconds. Go. Okay, the first one is bigger on top. What's the rule? No, wait, it's not. It's the same on both. What's the rule for those again, Miss Pap?
There's none, no bots. Oh, wait, sorry.
If it was a bot, but this one's not a bot.
Sorry, thought you were talking about the other one. Then it's a ratio of the lead coefficients.
So, final answer?
7/3.
And why did I use y equals?
Because it's a horizontal.
And I like it. Horizontals are the y, horizontals. All right, good. This one's a bot. This one's the one you were talking about that has no asymptotes. All right. This one is a bob. Would you agree that bigger on bottom is y equals 0? But there's a big asterisk next to that. It's y equals 0 plus. And I encourage you to actually write it that way for now, because if there's anything outside the fraction, like out here, let's say that there was like a plus 7 out here, then it would be 0 plus 7. The asymptote would be y equals 7. See, it gets moved up when you put something like that outside the function, and it would move it up, and the horizontal asymptote would have to move up with it. So why am I talking about this so much? Isn't the answer just 0? Yeah, this time. But if there had been a number on the outside, it would have been y equals that. And one more thing, this is the slant asymptote side note. If this had been a plus 3 out here, would you agree it would have been a y equals 3 asymptote? Are you with me there? Does it make sense to you so far? It's a bigger on top, sorry, it's bigger on bottom, and those are 0 plus what's on the outside. And so this would be 0 plus 3, y equals 3. You got that? Okay, so what if this had been 3x? Then it'd be y equals 3x. The asymptote is y equals 3x? Yes. So I graphed it just to make sure I wasn't losing my mind on this, and I'm not. It's a line like that, except it's an asymptote. At like y equals 3x, except it's an asymptote. So there is no horizontal asymptote, there's like a tilted asymptote. That's what happens if you have one that's bigger on the bottom and there's something outside. All right, so let me just see if you got that. Y equals 1 over x squared. Would you agree that's a bob? Plus 4x. Well, I was going to say it's 0, but now, what's the equation now? For the horizontal asymptote. Say it if you know it.
0 plus 4x.
Yep. It's bob, so it's 0. Plus whatever's on the outside. The outside is the 4x. 0 plus 4x is 4x. And that's where the horizontal asymptote would be. It would be a slant asymptote. Okay. And last but not least, this one. Bigger on the bottom, bigger on top, or same on both.
Bigger on top.
That's a bot. It's a rule for bots.
Um,
None. The horizontal asymptote is none. There isn't one. All right. So now we have to move on into what we really were supposed to be doing for today, which is learning how to set up equations for rationals. Actually, I'm wrong. We could practice one more here. Just tell me how to start this one. We won't even finish it. Just tell me how you'd start it. Well, by now, I hope you're starting with, if you can factor it, you should. And you can't. So what do? Clear the fractions. Did you think about multiplying by x plus 1 on both sides? That's what you should have thought. And then you're going to end up with a quadratic. And you'll have to set it equal to 0. And then if you can't factor it, you should. And it does factor when you get two answers and you're done. Okay, that's all there is to those. I love how that's supposed to be the easy part now. All right, I'd like you to finish that one. And just I think you could use the practice right here. Solve this quadratic. It will factor if you're doing it right. Once you get it set equal to 0, it'll factor. I'll pause for a second while you give that a shot. All right, so here's how it should have gone. X squared plus 5x plus 1x makes 6x plus 5. And on the other side, 2x plus 17. Then, personally, I would subtract the 2x and the 17 at the same time. That's a double step. A dubstep, you might say. But I like dubstep. Skrillex is my favorite. There. And then it's x and minus and plus and 6 and 2? No. What did you guys get? Did it factor?
Yeah.
So what was it?
It was x plus 6 and x minus 2.
Oh, okay. Good. I couldn't see it for a second. You're right. So then the answers are x equals 2 and x equals negative 6. Now, is this like, oh, I don't know, a time? In which case, negative 6 wouldn't make any sense? Or is it a length of a box side? In which case, negative 6 also wouldn't work? No. And in fact, if you check these, they would both work. Raise your hand if you got 2 and negative 6. All right, good. Now imagine what you would have done if this had said is less than or equal to 0 instead. That would open up a whole different thing. You'd make a number line, you'd have a negative 6 on the number line, and you'd have a 2, and you'd have empty circles there, and then you have to test intervals. Wouldn't that be gross? Yeah, that's what this one is. Okay, so your first step is you got to set it equal to 0. A lot of people think you can just test the intervals right off the bat. You cannot. It won't work. Okay? So, I'm subtracting 1 from both sides, but that's a little weird. You can't just subtract this 1 right here and make it like a negative 2. That does not work. How do you subtract 1 from this? I'm going to write it out how it actually looks. 3x minus 1 over x squared plus 1 minus 1 is less than or equal to 0. Well, yay, I've set it equal to 0, but now I have an issue. Oh my gosh, another algebra thing? Common denominator. Would you please find a common denominator, then put it all together, and then, if you can factor it, you should. And you will be able to factor it. Do you get we want to put an x squared plus 1 in here? That gives us a common denominator. Okay, if you couldn't do it, now you can. And now you can, this is the hard part. That simplifies down and then factors. Do you remember me giving you a hint earlier in the hour that if there's a negative leading term, it's smarter to factor out the negative first? Just factor out a negative 1. All right, give it a shot. I'll pause for a second. I'll give this a try.
X squared minus 3x.
Don't forget it's negative.
Yeah, negative x.
Negative x squared. That's this multiplying by this. Okay.
Yeah, plus 3x. Right.
I know what you're going to say, but let's just finish the, what did you have at first? You had negative x squared plus 3x, and then there's a number there.
0.
No, because this negative one, and you're thinking, oh, this positive one will cancel it. No, you forgot to distribute this, which happens all the time. That negative times that one makes it negative one, and another negative one, which makes it negative 2. All over x squared plus 1. It was a common denominator problem, so you don't add the denominators. Okay, if you had that wrong, it's because you had algebra issues, which really means anybody that's having issues with algebra, the top 20 is your first step on that. It's not like it solves all the world's problems, but if you get that done, once you get that done, then you're less likely to make little mistakes on things like that. All right, so how about I told you this out loud. I don't know if you processed it, but you should factor out a negative 1 now. So negative 1 comes out, and then you have x squared minus 3x plus 2. And the cool part about that is it'll factor. Final answer, negative 1, parenthesis, parenthesis, x squared plus 1 is less than or equal to 0. And this is an x, and this is an x, and Toby. It's not too many choices. You want to multiply the 2.
Yeah, minus 2 minus 1.
You got it. You caught the negatives. They both have to be negative to make this positive and to make the middle term come out negative. Okay, cool. Now, this is important. I'm going to go back to the directions here. Set one side equal to 0. Check, we did it. Use interval test. What are they talking about? This is where we set up the number line and we got to test intervals. But what are the key points? Ooh, I know some key points. The top has 2 key spots. 2 and 1. Those are key spots. 1 and 2. But is there any for vertical asymptotes? Nope. Know why? You should be looking for vertical asymptote, but there aren't any. There's no way to make the bottom 0. Seems like you could put in negative 1, but to think about it further, it does not work. You can't get the bottom to be 0, so there aren't any vertical asymptotes. If this would have factored, we would have put those on the number line 2. So it's whatever's on that makes the top 0 and whatever makes the bottom 0, they go on the number line. Now we've got to test it. Holy cow, this is a lot of work. Yep. We got to figure out what makes it less than or equal to 0. I would like you all to try putting in 3 because it's a nice, clean, easy number into this equation. Put a 3 in it and see, is it really less than or equal to 0? Okay, now there's 2 ways you can do testing intervals. One way is you can get the exact answer and find out exactly what happens when you put in a 3. But that is not the best way. 15-minute warning. The best way is to figure out if it's positive or negative. Because do you get, if this comes out to be positive, it won't be less than 0. If it comes out negative, it will be less than 0. Okay, so it's either going to come up positive or negative. So here's what I do. I go, okay, this is a negative for the first number. This one's going to be positive. This one's going to be positive. All over. That one's always going to be positive, no matter what you put in. Positive. I only have one negative. That means the answer is negative. That means it's less than 0. That means it worked. That means I should shade it in. All right, would you all try that for the number 0? put in 0, and figure out if we should shade it in down here or not. Put in 0 here, here, here. Get a little sign chart like this. Starts out negative for this, you know. Justin, is it negative, positive, negative over positive? Or is it negative, negative, negative over positive, or what is it?
It's negative, negative, negative over positive.
You got it. Because that one's negative, and that one's negative, and that'll always be positive. So there. What does that simplify to?
Positive over positive.
False. 3 negatives, make it negative. That one's negative. It's negative over positive, which is negative. So the answer is negative. So is that less than 0? Are negative things less than 0? Yeah. So it worked. So we should shade out here. So yay, I guess I should stay consistent and do it in black. There. Now it's not likely to work on the inside, but if you really wanted to know, you'd have to put in 1.5 and see if it comes out positive or negative. So I'm just going to prove to you it doesn't work. If I put in a 1.5, a 1.5, and a 1.5, my new sign chart would be negative for this. That one would be negative also. Now to be positive, all over positive on the bottom, because the bottom was always going to be positive. That one's positive. 2 negatives, cancel. That one's positive. Therefore, it's not less than 0, for it does not work there. There we go. Yay. Now, what's left? I got to be able to tell you how to set up these WordPress. So here's the key, everybody. It's always a rate plus a rate equals a rate. I know at this point in the hour, your brain's already tired and it's not fair and all those things, but you need to learn this. And this is the real key. So you are going to write a fraction. And this guy, his name is Chestnut, kind of a strange name. He's got a strange superpower. This is true. He actually won again this year.
Is his name really Chestnut?
Yep. I think that's his last name. But anyway.
Some people, yeah.
So this guy, he's got a freakish ability to stuff hot dogs down incredibly fast. And so anyway, he can eat 70 hot dogs in 10 minutes. 70 HD in 10 min. I strongly recommend the units. Everybody write this down. You need the units for the setup. After that, you can just solve this and it'll poof turn into a normal fraction problem where you just clear the fractions and sometimes you get a quadratic, sometimes you don't. But for right now, we need those units. Now the rate for Esper is not given. It asks us a question about Esper. It never says his rate, so I'm leaving that blank. Equals the rate for both of them. Both Chestnut and Esper can eat 100 hot dogs in 8 minutes. I don't like the way they said that. They should have said working together, they can eat 100 hot dogs in 8 minutes. So in other words, together, we don't know what their rates were separately, but we know together they're going to eat 100 HDs in 8 min. Okay. Now, if I didn't have any more information, it would be very difficult to solve this problem, but they did give me one more thing. Under the topic of Esper, they said 30 hot dogs. Because I have been careful with my rates, I know where to put that. I know hot dogs go on top. I'm putting 30 here. But do you get, we do not know how long it would take him to eat those 30 hot dogs, so I'm going to put my only variable, T. I could have picked X, but pick variables, pro tip, pick variables that use the same first letter as the unit. So like in this case, it's time. So
So
t's
would it
better
be-
than x.
Can you just put like the unit on this side and then not have to put it in every fraction?
I recommend when you set it up, and I've done a lot of these, just the setup one, just put the units in there. Because right now, I'm gonna strip all the units out and simplify this. Would you agree that 70 divided by 10 is 7?
Yes.
And I don't need units anymore. Plus 30 over t equals, and again, I don't need units anymore, but let's simplify 100 over 8. You could put 50 over 4, or what's even better? Simplify 50/4 one more time. 25 over 2, good. And do you get, look at that. We're back to the problem we started the hour with. It's not the exact same problem, but do you get, you just have to multiply everything by 2, and then multiply everything by t. And then you'll have to just solve it. Sometimes they come out to quadratics, this one doesn't. And when you're done, you know how long it takes this dude to eat 30 hot dogs. It's supposed to be the easy part. So watch. Times t, times t, times t, 7t plus 30 equals 25t over 2. Times everything by 2 now, clearing the fractions. 14t plus 60 equals 25t. And again, from there, you just have to divide or subtract 14, and you divide both sides, and you'll have your answer t. Okay? From there, it's supposed to be easy. Let's see if you've gotten that process of setting up the rate plus the rate equals the rate. Everybody write this. I know it seems dumb, but underneath it, try to set up this problem. When I was your age, I had to do some chores around the house to kind of earn my keep. Parents fed me, gave me a place to live. They didn't ask for much. They asked me to mow the lawn and occasionally help out. Okay? So the occasionally help out sometimes was helping my dad pick weeds in the backyard. I hated it. I hated it. It was hot. You have to bend all the way over to the ground or just be kneeling on the ground to pick the weeds. Anyway, but let's say that I could pick like 30 weeds in 10 minutes. Hint, start writing out the problem. My rate was 30 weeds in 10 minutes. Let's say my friend across the street was super motivated because I decided I don't want to pick weeds this long, so I'm going to pay my friend to help me pick the rest of these weeds. Okay? So he comes over and I say, I'll give you a dime a weed. Just pull weeds with me, and at the end I'll pay you a dime for every weed you pull. And so he's pulling weeds like a madman. And he pulls 50 weeds in 8 minutes. Then the question would be something like this. Working together, how many weeds could we pull in 10 minutes? All right. Did you know it was 30 weeds per 10 min for me? Does that make sense so far? Then my friend was 50 weeds per 8 min. Then the final one, working together, that's the total that goes here. How many weeds? So it's W weeds. Could have used X, but like I said, use something where it shares the first letter. So W weeds in 10 minutes. Now, it would have been really nice if I would have made them all 10 minutes each. But they're not going to be that nice. So I wasn't that nice. But it's that plus that. And now, this is the magical moment where you can drop the units and simplify. So what's 30 divided by 10? 3 plus 50 over 8 and simplify it and drop the units. What do you get? 25 fourths equals W over 10. Now, I could multiply everything by 40. I personally would have probably multiplied everything by 4 and by 10. But if you would have multiplied by 20, it would have been extra smart because it would have cleared both the 4 and the 10. But I'm not going to be that smart because I don't want you to think you have to be that smart. And then you could multiply everything by 10. And that cancels that. And I got 120 plus 250. 120 plus 250. Is that 370, I think? Equals 4W. Divide by 4. Divide by 4. Whatever 370 divided by 4 is. Okay. Do you get what I just taught you is a lot? It's at least half of the test. In fact, I'm even going further. I think we just covered 2/3 of the test. Okay? Test is not tomorrow, don't worry. But do you get that if I asked you 3 years from now, what did we do today? You wouldn't remember a darn thing. It'll all leak out of your head. What would make it stick better?
If you wrote it down.
Yep. And if you do some practice tonight. Do it one more time with a little gap in there. You know, you're going to do some English and reading, whatever, and then you come back to this later tonight and do a couple practice problems. That'll make it stick. I know some of you are being slackers about your homework. It's your life, but I'm warning you, you don't do any of the practice problems, you're going to be really lost. This test is going to kick your butt. If you practice, it won't be that bad. This is even hard for me. All right. That's all I got for you for today.